Hi, this is Sir Absolon of Math Alas channel, and welcome once again in another episode of Learning in Mathematics.
Today's lesson is
finding the first term and the common ratio of geometric sequence.
Geometric sequence or geometric progression is a sequence in which each term is obtained by multiplying the preceding term by a common multiplier called the common ratio.
consider the sequence 3, 6, 12, 24, 48, and so on. Each term is doubled to obtain the succeeding term. Thus, the common ratio of the sequence is 2.
Before we continue, Adi, Kuya, Nene, Tete, please subscribe to my daddy's channel, Salamat.
This formula is a sub n equals a sub 1 times the common ratio raised to n minus 1. We will use this formula to solve for the first term and the common ratio of a geometric sequence. Let's consider these examples. Example number 1. Find the common ratio of a geometric sequence if the first term is 1/3 and the 8th term is 128 over 3. We know that there are 8 terms in the given sequence. So the first term is 1/3, the 8th term is 128 over 3, and n is equal to 8 since we're talking about 8 terms in the sequence. So to find the common ratio using the geometric sequence formula, we will substitute these values. So we have 128 over 3 equals 1/3 r raised to 8 minus 1. So to solve for r, we have to multiply both sides of the equation by 3 so we can eliminate the fractions. So 3 times 128 over 3, cancel na si 3, you'll have 128 equals r raised to 7. Now, to solve for r, we have to get the 7th root of both sides of the equation. So, what is the 7th root of 128? So, to do this, we have to rewrite 128 in exponential form. In such a way, its exponent should be 7. So, we know that 128 can be rewritten as 2 raised to 7. So, if you get the 7th root of these equations, we have r equals 2. Kasi, 7th root of 2 raised to 7 is 2. Cancel na tong si 7. So, you will have 2. 7th root of r to the power of 7 is r. So, r is equal to 2. In this example, the common ratio of the geometric sequence whose first and 8th terms are 1/3 and 128 over 3 is 2. Let's have another examples in finding the common ratio. Find the common ratio of geometric sequence whose first and 6th terms are 2 and 64 respectively. So we know that there are 6 terms in the given sequence, and that the first term is 2, the 6th term is 64, and n is 6. So again, using the geometric sequence formula, we substitute these values. 64 equals 2 times r raised to 6 minus 1. Now, we have to divide both sides of the equation by 2. So we have 32 equals r to the 5th power. Again, we have to get the 5th root of 32. So, to solve for r, we know that 32 can be rewritten as 2 raised to the 5th power. So, if we get the 5th root of both sides of the equation, we have 5th root of 2 to the 5th power is 2. So, r is equal to 2. Let me show you an alternative solution on how to solve for the common ratio. We can solve for the common ratio using this formula. So, you have to divide the last term, a sub n, by a sub m, and that the exponent of the common ratio should be n minus m. So, how are we going to use it? So, we know that the sixth term is 64. 64 divided by 2. Now, 64 is the sixth term of the sequence. That's why you have 6 here on top. So, 2 is the first term. So, you have 1. So, the exponent of r should be 5. Now, 64 divided by 2 is 32. Now, getting the fifth root of both sides of the equation, you will have r equals 2. So, in this case, you can solve it mentally. So, balikan natin ha. You take 64 divided by 2, then get the fifth root of 32. That's because 6 minus 1 is 5. So, that's why you have to get the fifth root of 32. Now, in this problem, the common ratio of the geometric sequence whose first and sixth term are 2 and 64 respectively is 2. Let's take example number 3. In this case, we have to find the first term of the geometric sequence whose second and fifth term are 16 and 1024 respectively. So, we know that there are 5 terms in the given sequence. And the sequence looks like this. We don't know the first term. So, to solve for the first term, we assume that 16 will be our first term and that 1024 will be the fourth term. So again, i-assume natin na si 16 ay yung first term at yung 1024 ay fourth term. So we have a sub 1 is equal to 16, a sub 4 is equal to 1024, and we are only talking about 4 terms. So to solve this, we have to find first the common ratio before getting the first term. So using the geometric sequence formula, we substitute these values. We have 1024 equals 16 times r raised to 4 minus 1. Again, we have to divide both sides of the equation by 16. So we have 64 equals r to the third power, or r cubed. Now, we have to rewrite 64 in exponential form. So, if we get the cube root of 64, madali nating makuha si r. So, 64 can be rewritten as 4 cube. So, if we get the cube root of both sides of the equation, you will have r equals 4. Kasi makakancel na si 3. So, since r is equal to 4, then, to get the first term, we have to divide the second term now, which is 16, divided by the common ratio. So, 16 divided by 4 is 4. So, the first term of this sequence is 4. Now, again, using the alternative solution in finding the common ratio, we can start solving for the common ratio by dividing 124 by 16. So, ito yung kagandahan. So, 1024 divided by 16 is 64. Now, we have to get the cube root of 64 kasi we're talking about the fifth term, 5 minus 2, that is 3. Kaya dapat ang exponent ng r is 3. So, getting the cube root of 64, r should be 4. So, from this, since we know that r is 4, we can get now the first term. 16 divided by 4 is 4. Therefore, the first term of the geometric sequence whose second and fifth term are 16 and 1024 is 4. Note that solving for the first term of the geometric sequence is a two-step problem. First, you need to solve for the common ratio. Then, solve for the first term. Please pause this video and try these exercises. And don't forget to type your answers on the comment section.
That ends our lesson for today, and this is Sir Sunny Bugawisan of Matalas Channel. And always remember, in Matalas Channel, we are making mathematics more easy. Bye-bye! See you again next time. That ends our lesson for today, and this is Sir Sunny Bugawisan of Matalas Channel. And always remember, in Matalas Channel, we are making mathematics more easy. Bye-bye! See you again next time.